Hello, everyone. This is Xingzhe Zhang from West Michigan University. I'm presenting my poster, Enhance the Performance of Triboelectric Nanogenerator using Custom Fabricated PDMS. I would like to start with an introduction about the developed TENG. A flexible TENG was fabricated for energy harvesting application. The TENG consists of PDMS as an anode layer, PVDF as a cathode layer, copper foil and aluminum tape as electrodes. The PDMS was prepared by mixing pre-polymer and Qiang engine in ratio of 10:1 and 5:1, and then barcoded on a copper sequentially. The PVDF was attached on an aluminum tape. The capability of the TENG related to open circuit voltage and short circuit current was tested in a frequency of 3 Hz, 5 Hz, and 7 Hz at 7 and 30 Newton. The maximum of 146 volt and 44 microampere was measured respectively. The fabrication step involved in the preparation of the anode layer. 90% of the PDMS pre-polymer and 10% of Qiang engine was mixed barcoded onto copper substrate for the first layer. Then 80% of PDMS pre-polymer and 20% of the Qiang engine were mixed and barcoded on the first layer of the PDMS. The structure on the picture of the TENG was shown in the middle. The standard method of TENG is a vertical contact separation mode due to its reported high power density compared with other modes. Because this mode TENG developed high voltage in between the electrode due to the vertical mechanical triggering. For experiment setup, function generator was connected to a shaker through a power amplifier. The fabricated TENG was mounted to the shaker and applied the force on the TENG. And then it was connected to the oscilloscope and source meter for the real-time plotting. The performance of the fabricated TENG was investigated by compared with the two other TENGs. One TENG was fabricated with PDMS with a 10:1 ratio, result in sticky PDMS surface, and the other PDMS mixed in 5:1 ratio resulted in the harder PDMS. We can see that the OCV of the developed TENG is higher when compared to the other two teams. We can also see that the short circuit current and the open circuit voltage of the developed TENG is directly proportional to the frequency. When the frequency is increased, the both current and voltage is increased. Conclusion: a flexible TENG was fabricated using PVDF and PDMS. It was calculated that a maximum power density is 1.6 microwatt per centimeter square. The result demonstrates that the custom-made PDMS with lesser surface thickness and hardness led to significantly improved of the voltage and current when compared to the commercial PDMS, which is a 10:1 ratio. The future work is focused on the optimize the performance of TENG in terms of the thickness and dimension of the TENG. Thank you.